So hi everyone, so today in this video we will be discussing an interesting Codeforces problem from Codeforces round 925 div 3 and it is rated 1700. The problem goes by the name chat screenshots. So what does this problem say is there are n people in the programming contest chat. Chat participants are ordered by activity, but each person sees himself at the top of the list. For example, we are given with n equal to 4, that is there are 4 people in the chat and their order is 2314. This is some kind of order. It doesn't matter us that which type of order it is just a random order which is given. Then the first user sees this order, second user sees this order, third user sees this order and fourth user sees this order, right? So every user will see himself or herself first at the beginning and then the remaining from this given order, right? So out of this n people, k people decided to post this screenshot of their order which is visible to them, right, which shows the order of participants shown to this user. The screenshots were taken within a short period of time and the order of participants has not changed. So our task is to determine whether a certain order is possible from these given orders or not, right? For example, if we consider the same test case, so let me explain you in this board, right? So we are considering this example. So here n is equal to 4 and k is equal to 4, and also our k can be less than or equal to n, right? So here n and k are same and the orders given are 1 2 3 4, 2 3 1 4, 3 2 1 4 and 4 2 3 1, right? Okay, this is given to us, right? And we have to determine whether a valid order is possible to be deduced from this given orders or not. So according to the first user, so according to this user, 2 should come before 3 and then 3 should come before 4. So 2 should come before 3, right? 2 should come before 3 and 3 should come before 4, fine. Then according to the second user which posted his screenshot in the chat, according to him 3 should come before 1. Okay, 3 should come before 1, that means 1 will be present either here or either here, and 1 should come before 4, so 1 should come before 4, so 1 must be present here, right? So let me write down this clearly. So 1 will be present here and 4 will be present here. Now according to the third user, 2 should come before 1 and 1 should come before 4, so 2 is coming before 1, okay, and 1 should come before 4, which is good. Now according to the last user, 2 should come before 3, okay, 2 is coming before 3 and 3 should come before 1, so 3 is also coming before 1, which is fine. So when we try to deduce a possible order out of these given orders, we do not face any type of contradictions, which means that this is a valid order, right? This is a valid order. So where does this problem is hinting towards? If we see, then what we wanted is, we wanted that 2 should come before 3, 3 should come before 4, 3 should come before 1, 1 should come before 4, right? So this is pointing towards a topological sort problem, or topological sort solution rather, right? So what we will do is, to check if a valid order is possible or not, we will direct the edge from this to this. So here it would be like, we will direct the edge from 2 towards 3 and then from 3 towards 4. Similarly from 3 to 1 and then from 1 to 4, right? Then from 2 to 1 and then from 1 to 4, which is already done. Then at last 2 to 3 and 3 to 1. 2 to 3 done and 3 to 1 is already done too, right? So we have constructed this graph, right? So if we observe carefully, then we there is no cycle present in this graph, right? There is no cycle. So this is an acyclic graph, right? This is an acyclic graph. And where do we observe acyclic graph? We observe acyclic graph in the condition of topological sort. We know the condition for topological sort is. What is the condition of a valid topological sort? So if we want a valid topo sort, then the given graph should be DAG, right? That is directed plus acyclic, right? Directed plus acyclic. So this graph is directed, okay, and it is also acyclic, which means that this graph can have a valid topo sort, which is this one. This order is a valid topo sort, right? Okay, this order is a valid topo sort. And if a valid topo sort is possible, we just have to print I guess yes or no. Yes. So if a valid topo sort is possible, we just have to print yes. So for this test case, the answer would be yes. And if it is not possible, then we will print a no. So let's consider an example where a valid topo sort will not be possible, right? So consider this example where this one, where n is 3 and k is also 3, and the screenshots of the users given are 132, 213, 321, right? So according to this, there are 3 users, right? There are 3 users. So according to this user, 3 should come before 2. 3 should come before 2. Okay, so we'll direct the edge from 3 to 2. Also 1 should come before 3. Okay, 1 should come before 3. So we'll direct the edge from 1 to 3. And at last 2 should be directed to 1, or rather 2 should come before 1. According to this user, 2 should come before 1. But here 1 has already came before 2. So it is not possible to make 2 come before 1. And if we try to observe the same thing in form of graph, then we will realize that we have to direct a graph from 2 to 1, right? So we will direct a graph from 2 to 1. And clearly here a cycle is getting formed. This is a cycle from 1 to 3, 3 to 2 and 2 to 1. So this is a cyclic graph. And since it is a cyclic graph, then a valid topo sort for this graph will not be possible, right? Valid topo sort is not possible for this graph. And since a valid topological sort will not be possible for this graph, we will print no. So this is all that this problem asks from you, right? So coming into the coding part, so we have to take the inputs of n and k as mentioned in the question, and we want to take the input for k screenshots, right? And each k screenshot will have n integers. So we will be storing these n integers in a vector, say name screenshot, right? It represents an individual screenshot. For right? After the input of each screenshot is done, we will push it towards a bigger screenshot that will collect all of these smaller screenshots. Right? So let me declare it here. So it will be vector of long, because it has to store all of the individual screenshots. So now after the input has been done, okay, so now the input has been done. So what we want to do now is we want to construct the graph using this input, right? So for this we will be using an adjacency list, right? We will be using an adjacency list. I will be using one based indexing here also, and we will be iterating through each of the screenshot that is present in this bigger screenshots, right? So this IT represents a bigger screenshot. Small typo here, right? Okay, and going through each of this integer from one based indexing, as I told that we do not need to do anything with the first integer, we need to start from the first index, right, till the last index. So the same thing I will be doing here, and since its size is n, we know, so we'll just do n minus 1 so that we can direct the edge from u to v. And just to make sure that the same edge is not present between the two nodes, again I will do a check, rather so yes. So using this if condition will ensure that if an edge is present between two nodes, then again a new edge will not be constructed, right? So I will direct the edge from this u to this v, it of I plus 1, right? Once this has been done, once the graph has been constructed successfully, I will be using the concept of visited and path visited to check the cyclic condition, right? So we will use two arrays, namely visited, and I will also be using one based indexing here only, and path visited, right? So now I just have to go through each of the node and see if it is not visited, then I will call the DFS function, right? If this is not visited, that is if this I is not visited, then I will call the DFS function, and if at some point of time in future it returns a true, that is a cycle is present, right? It returns a true, that means a cycle is present, and if it is a cycle is present, we have to print no, and then I will return. And if it is not the case, like it never happened, so we just have to print yes, right? Right, so what parameters we would be passing is, we would be passing visited, path visited, and adjacency list, and we will also be passing the initial starting node, which is here I, right? So let's write down the DFS function, which will be of boolean type, since it has to return true or false. So let me copy this because I have to write it several times here, I guess. So initially we have the node, and then we have the visited array, and then I have the path visited array, and then I have the adjacency list, right? So visit this node as mark this node visited, also mark this node as path visited, just a simple cyclic check concept, path visited, and now I have to iterate through each of its neighbors in the adjacency list for this node. If it is not visited, that is the neighbor is not visited, then we will call the DFS function, and if at some point of time in future it returns a true, that is it has detected a cycle, so we will return a true by here only, right, by here only. And if it is visited and it is also path visited, if it is visited and it is also path visited, and it is also path visited, then we will return a true. Has never detected a cycle, we will return a false, right? So what parameters will be passing through this DFS? So the current adjacent node will become our new node, that is IT. Visited will remain as it is, path visited will remain as it is, and we will also be passing the adjacency list, right? So this will be the complete code, I guess. And also don't forget to mark this node path visited, unmark this, right? We while backtracking we have to unmark this node as path visited to be 0, right? So now if we try to run up this code, like this is our required input and this is the expected output, right? This is a given input and this is the required output. So let me run this up. So I think we are getting the correct answers, right? So let's try to submit this in the platform itself to verify the correctness. I think this should work. So our solution is correct. So if you have any doubt, feel free to comment in the comment section. I will try to help you out. See you in the next video. Thank you.